So we're talking about domain, range, and end behavior. If you take a look at this first number line, we're going to express this as simply an inequality. So that's the first step. The -3 is not included, so I'm going to say that the interval would be from where x is greater than but not equal to -3, and it goes on from there, right? So that's just a simple inequality to represent that interval. All of the x values from here all the way on into infinity. If we were going to put that in set notation, this is what it would look like. We use a brace and then x. And what we're saying is with this line, we're saying all of the x's where. And then we simply write that inequality in here. So x is greater than -3. And then we close it with a brace. So that's set notation. It looks a little funky, but really you're just writing your inequality inside two braces. And that's really pretty much it. Interval notation, what that means is we're describing this in just a slightly different way. So when it does not include the number, we use a parentheses. So it'll be like this, a parenthesis. And so we'll put that there. That does not include -3. We use a comma, and then we describe where it goes off to. Well, where it goes off to is actually infinity. It goes on forever. So we're going to put that infinity right here. And we don't include infinity. If we were going to include it, we would put a bracket. But because you can never get to infinity, we don't include it, so we just use a parenthesis like that. All right, let's try it again. So let's describe number 2. This is going to be all of the x values that are greater than 15. So we'll put that down. That's just a simple inequality, right? If you were going to write it in set notation, you would use a brace, and you would set all of the x's from, and so then you'd put your inequality in here. X is greater than 15. And then you close it with a brace. And then for interval notation, what we're going to do is say we're not going to include 15, so we're going to use a parenthesis, right? So 15 right there. And then we'll do comma, and we're going to describe where it goes off to. Well, this time it doesn't go off to infinity. It goes off to 26, and then it stops. So we're going to include 26. That means we're going to use a bracket. And then we just put 26 right here. So there's interval notation. Okay. So now we're going to describe domain and range. Domain and range, domain is just a fancy way for saying all of the x's. And range is saying all of the y's of a specific function. So if we look at this function right here, let's describe the domain. So as an inequality, all of the x's, let's just write that here, okay? All of the x's is what we're talking about. And let's write a simple inequality. Well, simply put, x is all of the real numbers. It's like every single one of them. So instead of writing an inequality, we're simply going to put this symbol. It's like 2 lines, and then you write an R. That means all real numbers. That's what that means. Okay? So in set notation, how would you write it? Well, pretty much the same way. All real numbers. What about interval notation? Well, if you look at the x's, okay, where does it go? Where does this function go? It goes along all of them. This will go on and on and on into infinity. And so it will cover every single conceivable x value along that axis in both directions. So that means that we're going to write it goes from -infinity, all of the negative x's, all the way through to all of the positive x's. And it does not include either of them because you can never get to infinity. So we write it like that with 2 parentheses. All right, let's look at the range. For the range, it does have a stopping point. The stopping point is actually right here, right? For range, it does stop at 3. So we can write y is less than or equal to 3. Okay, so there's our inequality. And we're using y because range is all of the y's. And so we're looking at the y-axis here. So it does stop at 3. In set notation, you would simply say brace, and then you say all of the y's where y is less than or equal to 3, and close it with a brace. In interval notation, what you're saying is that you're going from 3, or actually rather, you're going from negative infinity. You see, this is going all the way down to negative infinity. It's going on and on and on in that direction. And then it's peaking at 3. So on to 3. And that's that. That's all of the y values that you can take from this. It will go on in infinity down here in the negative direction, but then as you come up to the positive direction, it stops at 3. So we're going to include 3, so we'll use a bracket, but we're not going to include negative infinity because you just can't get to infinity. All right, let's talk end behavior for a moment. So if you look at this function, what does it do at the end? If you look at where the goes to infinity, okay, so if you look at, as x is going on into infinity, what happens to the y? So now let's talk just about maybe just finding range if we're just given a function. So it says, let's graph this thing and then find the range, all right? So first off, this is a y equals mx plus b. This is slope-intercept form. So here's my slope and here's my intercept. So let's just plot that. Here's my intercept. And then as we plot this line, we can just use the slope, right? So we're going to go back 1 and up 3. So back 1, up 3, right? Back 1, up 1, 2, 3. So here's my next point. And then we're just going to do that again. We're going to go down 3 over 1 like this. There's my next point. Let's do it again. Down 3 and over 1. So that's right here. So we get our line plotted. So let's pass a line through all of those there. Okay, pretty good. So, and it says with this domain. So hold on. There we go. So with this domain, this is the domain. It does not include 1 or negative 1. So domain means all of the x's. So let's look at where x is negative 1. That's right here. So at x equals negative 1, this is where the line actually has an open end. Okay, this point is not included in this graph. And then as we go on to 2, so let's go from negative 1 to 0 to 1 to 2. Once we get to 2, we're down here, okay? And this point is included. Do you see the bracket? So that 2 is included, so that's a solid circle, and so this is our graph, okay? This is our graph using this domain, parentheses, negative 1, comma, 2 with a bracket. If you simply look at where the, as x, what we're saying is that f of x, right, as x is going through on into infinity here, as it's going this way, what's happening to the output of the function? Well, the output of the function is going into negative infinity, right? This is diving down, and it does that into infinity. And then as x goes to negative infinity, so as we approach, so this is positive infinity for x, right? As x goes to positive infinity here. So as we go in this direction, as x goes to negative infinity, what happens? Well, this function, the output of the function, the y value, goes and dives into negative infinity again, right? So as x goes into negative infinity, so does the value of y. Y goes down into negative infinity as well. Okay.